Welcome to chemistry class. So today's topic is DD transition. DD transition in complexes or any other ionic compounds of transition elements are responsible for colors. So in presence of ligands like water, ammonia, like that, some of the compounds, some of the salts of transition elements will exhibit colors. So the prime responsible for that colors are DD transition. So let us see, in absence of field, any field, that means electric field or magnetic field, all d orbitals are degenerated. We know that there are 5 d orbitals. So these 5 d orbitals are degenerated in absence of field strength. Okay. So if there is field strength, then the d orbitals split into two sets after disappearing of degeneracy. So among the two sets, one set or higher energy is to be considered as higher energetic, and the another set is to be considered as lower energetic. So the energies of two sets will be decided by the geometry of the salt or particular complex. Here let us see, and now I am discussing DD transition in octahedral geometry. So here in octahedral geometry, the d orbitals for the compounds having octahedral geometry, d orbitals split into two sets usually in presence of ligands. Then the two sets is to be considered as, the one set is the orbitals in which the lobes are in between the axes. This set is to be considered as T to G. Okay. So now let us see, the another set is EG. Okay. So after disappearing degeneracy in d orbitals, the d orbitals split into two sets. Okay. So one set is T2G, another set is EG. Is it clear? So now, when you consider the degenerated d orbitals like this, here 5 lines indicates 5 orbitals present in d orbital. See here, if you place this in presence of ligand like water, ammonia, anything else which can give the electron is said to be ligand. A species which can donate electron, a species which have some extent of charge more than usual is said to be ligand. Okay. So now let us see, if you place a complex with octahedral geometry in a solution of ligand. Okay. So then these are 5 degenerated d orbitals, and then they goes to next level. After that the splitting will take place. Here 3 orbitals, 2 orbitals will be appear at higher energetic level, and 3 d orbitals will appear in lower energetic level. This pattern will be observed in case of octahedral complexes. In case of octahedral complexes. See here, these orbitals is to be considered as Eg orbitals. These orbitals is to be considered as T2G orbitals. Okay. So if an electron transfers from either orbital, okay, like this, then this is said to be DD transition. DD transition. DD transition is nothing but exchange of electron or transfer of electron from lower energetic orbital to higher energetic orbital, and vice versa. Okay, higher energetic to lower energetic orbital. During this process, some extent of energy will be released. Some extent of energy will be absorbed at first, and then some extent of energy utilized, and then remaining energy will be released. Okay, the released energy will appear as color. Okay, the energy gap between these two orbitals in case of octahedral complexes is to be considered as delta O. Okay, here delta O means crystal field stabilization energy. Crystal field stabilization energy. Although the metal ion is same, okay, it will exhibit different colors when it is in combination with different anions. Okay, so that will be depends upon the magnitude of crystal field stabilization energy. అంటే ఇక్కడ ఏంటంటే కొన్ని అయాన్స్ ప్రజెన్స్ లో ఏమో ఈ ఎనర్జీ డిఫరెన్స్ తక్కువగా ఉంటుంది, కొన్ని అయాన్స్ ప్రజెన్స్ లో ఏమో కొన్ని అయాన్స్ ప్రజెన్స్ లో ఏమో ఈ ఎనర్జీ డిఫరెన్స్ అనేది ఎక్కువగా ఉంటుంది. అంటే మెటల్ ట్రాన్సిషన్ మెటల్ ఒక్కటే అయినప్పటికీ అది సల్ఫేట్ తో ఉన్నప్పుడు ఒక కలరు, నైట్రేట్ తో ఉన్నప్పుడు ఒక కలరు, అసిటేట్ తో ఉన్నప్పుడు ఒక కలరు, ఇలా కార్బోనేట్ తో ఉన్నప్పుడు ఒక కలరు, ఇలా డిఫరెంట్ కలర్స్ ని ఈ ఒకే మెటల్ క్యాటయాన్ ఎగ్జిబిట్ చేస్తుంది. దీనికి రీజన్ ఏంటి అంటే డిఫరెన్స్ ఇన్ crystal field stabilization energy in presence of different anions during DD transition. So here I am showing the colors of the copper compounds. Example I am taking is copper. You know that the configuration of copper is 3d9 4s2. Okay. So if you write this in box model, these are 5 d orbitals and this is s orbital. Okay, this is 3d orbital, this is 4s orbital. Okay, so 4s orbital is fully occupied and 3d orbitals, the configuration of 3d orbitals is like this. Okay, so this is the electronic configuration of copper. Okay, you know that copper is transition metal. So the most stable cation of the copper is Cu2 plus. So if you write the configuration of electronic configuration of Cu2 plus, then it is 3d9 4s0. Okay, now let us see the electronic configuration of Cu2 plus ion. Okay, Cu2 plus ion. Four s orbital లో అసలు ఏం ఎలక్ట్రాన్స్ ఉండవు అన్నమాట, అంటే 4s0. సో నేను ఇప్పుడు రెడ్ కలర్ తో ఒక ఎలక్ట్రాన్ ఏదైతే వేసానో దట్ ఈస్ ద రెస్పాన్సిబుల్ ఫర్ DD ట్రాన్సిషన్ ఇన్ కాపర్ ఇన్ ప్రెజెన్స్ ఆఫ్ ligand or in presence of field strength. Okay, see here what will happen in case of copper when it is in octahedral geometry. Cu2 plus ion when it is in octahedral geometry. Okay, so as I told, there are 5 degenerated orbitals in absence of field. When a field strength is applied, then the first level of excitation takes place. In first level of excitation also there are 5 d orbitals are in degeneracy. Okay, see now the electronic configuration. Okay, this will be like this, and then the second level of excitation takes place like this. Okay, in second order excitation, being it is in octahedral geometry, the splitting pattern will be like this. Okay. So here, the orbitals at top end is to be considered as EG orbitals, and the orbitals at bottom is to be considered as T2G orbitals. Okay. Here, no issue with paired electrons usually. So here an unpaired electron is there that will goes to EG orbital at first. After that, the transition of this electron from EG to T2G takes place. Okay. So during this transition, if T2G orbital goes to EG orbital, then absorption of energy takes place. Absorption of energy takes place. Again, when electron comes from EG to T2G orbital, then because it is de-excitation, energy will be emitted in the form of light. Okay, this emitted energy will be appear as color. Emitted energy is to be appeared as color. So this is the process happening in case of Cu plus 2. So in case of any transition metal cation, this is the process taking place and it is responsible for color. Okay. So for a cation or for an atom to possess color, the prime condition is it should have at least one unpaired electron. Okay, because of this electron only transition takes place and color will be appear. Now let us see the colors in the copper compounds.